Dot product is also called scalar product. Given two vectors A and B, their dot product, A dot B, is defined as A's magnitude times B's magnitude times cosine theta, where theta is the angle between A and B when they are connected head to head or tail to tail, and theta is between 0 and 180 degrees. The result is a number or scalar. Remember, dot product of two vectors is not a vector. It's a scalar. For example, A's magnitude is 3, B's magnitude is 4, theta is 60 degrees. They are shown in the diagrams. Notice the two vectors are connected either head to head or tail to tail. Using the formula, A dot B is A's magnitude times B's magnitude times cosine theta, which is 3 times 4 times cosine 60 degrees. The result is 6. It is a number, not a vector. If theta becomes 90 degrees, or A and B are perpendicular to each other, then A dot B is 0, because cosine 90 degrees is 0. As a matter of fact, A dot B is 0, is equivalent to, A and B are perpendicular. We can use this feature to check if two vectors are perpendicular. If theta becomes 120 degrees, then A dot B is 3 times 4 times cosine 120 degrees. Cosine 12 degrees is minus half. So the dot product is minus 6. We can see, since a vector's magnitude is always positive, the dot product is negative when the angle between two vectors is obtuse, because cosine value of an obtuse angle is negative. The dot product is positive when the angle is acute, and 0 when it's an right angle. I dot I is I's magnitude times cosine 0, because the angle between I and itself is 0. I's magnitude is 1, cosine 0 is 1, so I dot I is 1. For the same reason, J dot J is 1, and K dot K is 1. Since I j k are perpendicular to each other, I dot J, I dot K, J dot I, J dot K, K dot I, K dot J are all 0. Now let's see how to calculate the dot product of two vectors in the component form. AI plus BJ plus CK, dot DI plus EJ plus FK. We can multiply them like two polynomials. This is ADI dot I, plus AEI dot J, plus AFI dot K, plus BDJ dot I, plus BEJ dot J, plus BFJ dot K, plus CDK dot I, plus CEK dot J, plus CFK dot K. Among all these dot products, only I dot I, J dot J, and K dot K are 1. Others are all 0. So the result is AD plus BE plus CF. Therefore the dot product of two vectors is the sum of the product of their corresponding terms. For example, 2i minus 3j plus 4k, dot I plus 2j minus 3k, is equal to, 2 times 1 minus 3 times 2 minus 4 times 3, which is minus 16. You can also write them as column vectors. Minus 215.134, is equal to, minus 2 times 1 plus 1 times 3 plus 5 times 4, which is 21. A dot B is A's magnitude times B's magnitude times cosine theta. If we know two vectors in the component form, we can calculate A dot B, A's magnitude and B's magnitude, and hence find the angle between them. Let's look at an example. A is 2i minus 3j plus 4k. B is I plus 2j plus 3k. Find the acute angle between them. First, let's find A dot B. It is 2 times 1 minus 3 times 2 plus 4 times 3. This is 8. A's magnitude is the root of 2 squared plus 3 squared plus 4 squared, which is root 29. B's magnitude is the root of 1 squared plus 2 squared plus 3 squared, which is root 14. So cosine theta is A dot B over A's magnitude B's magnitude. It is 8 over root 29 times root 14. And theta is inverse cosine of this value. Using your calculator, you can find it as 66.6 degrees. If the dot product is negative and the question asks for the acute angle, we can ignore the sign of the dot product, because cosine 180 degrees minus theta is minus cosine theta. For example, if in the above question, b becomes I plus 2j minus 3k, then the dot product becomes minus 16. Since the question asks for the acute angle, we can ignore the sign, and get cosine theta as 16 over root 29 times root 14. Using the calculator, we can find the angle as 37.4 degrees. Let's review the example from last section. This is a prism, and the cross-section is a semicircle with radius 6 cm. The length is 20 cm. The top edge is EF, and EP is 8 cm. Now use dot product to find angle APN. From last section, we know, NP is minus 6i minus 2j plus 6k. AP is 6i plus 8j plus 6k. Angle APN is the angle when NP and AP are connected head-to-head. So it is the angle used in dot product. Therefore, cosine angle APN is NP dot AP over NP's magnitude times AP's magnitude. NP dot AP is minus 6 times 6 minus 2 times 8 plus 6 times 6. NP's magnitude is root 6 squared plus 2 squared plus 6 squared. AP's magnitude is root 6 squared plus 8 squared plus 6 squared. So cosine angle APN is minus 16 over root 76 times root 136. This is negative. Therefore angle APN is obtuse. Using the calculator, we can find inverse cosine of this value. So angle APN is 99.1 degrees. In this class, we learned dot product. A dot B is A's magnitude times B's magnitude times cosine theta. Theta is the angle when we connect A and B either head-to-head or tail-to-tail. We can find theta by using inverse cosine A dot B over A's magnitude times B's magnitude.